Earth science is the study of the Earth. This is Norris Teaches Science. We're in another Earth Science Edition video. This video, we're going to start talking in the series about the lithosphere. It's going to go on for a few videos. I'm Mr. Norris, and today we're going to talk about Earth structure. We need to understand the structure of the Earth for us to be able to understand all the processes that happen with the Earth. So by the end of this video, I can describe how the Earth is structured from core to crust. So let's talk about it. The structure is based off layers, and the layers are determined by either the composition, which means the makeup, or the physical properties, means like how it actually works. So we're going to first talk about layers by composition, and when we divide the Earth by layers of composition, we're going to divide it into three: the crust, the mantle, and the core. The crust is the outer, the mantle is the major inner, and the core is the center. The crust is actually really thin compared to the rest of the Earth. If you think about it, like an apple, if you cut an apple, the skin of the apple is the crust, all the meaty stuff is the mantle, and that center core stuff is the core. But the crust is a thin, rocky outer layer. It's mainly composed of oxygen, silicon, aluminum, and iron. And it can either be continental, which is usually thick, or it can be oceanic, which is pretty thin compared to each other. The mantle is about 82% of Earth's volume. It's solid rock at the top and liquid rock at the bottom. Its composition is mainly magnesium. It's about 2,890 kilometers thick. And the core is composed mainly of iron-nickel alloy. An alloy means two metals combining together on an atomic level. And there's extreme pressure found near the center. It's also very, very hot. Now, if we divide the layers based off physical properties as we go from outside of the Earth inward, we start with the lithosphere, and then we go into some of the asthenosphere, and then we get to the mantle. Just like we talked about in the past slide about the mantle stuff comes back in here. The mantle is still part of physical properties. Then you have your outer core and your inner core. I know I'm really bad at using the mouse to highlight things. All right, let's talk about lithosphere. Lithosphere is the crust and the uppermost mantle. Solid material. That's the big thing there. It's solid. It's cool. It's rigid. Shell can be about 100 kilometers thick if you include the crust and the mantle part. The asthenosphere is right below the lithosphere. It's kind of part of the mantle, kind of not. It's like its own little sphere. It's soft, it's solid, it's very weak, it's close to melting. I kind of think of the property of the asthenosphere like when I'm melting chocolate to make dessert. I'm melting the chocolate and I'm doing it in the microwave because I'm trying to do it quickly. And I'm trying to make sure I don't burn the chocolate. So I'm only placing in there for seconds at a time. It gets to a point where it looks like it's still a chocolate chip, but if you touch it, it just is very malleable. And so that's kind of what I think of when I think of the asthenosphere. Of course, after the asthenosphere would come the mantle, which we already talked about, liquid rock, big portion of the whole thing, of the whole layers. And then you come to the outer core right after the mantle. It's a liquid section. It's about 2,260 kilometers thick. Its composition is iron. This is where most of the iron is going to come in. And its purpose is to make the magnetic field. As it's rotating, it makes that magnetic field. And we talked in the astronomy section of these videos about what the magnetic field does. So if you don't remember, go check out the Sun-Earth relationship video, and that should help you out with understanding this material. And then after the outer core, right in the center is called the inner core. It's a solid layer. It's solid because of the high temperature and high pressure. Under extreme pressure, things become solid. It's nickel in composition, and its radius is about 1,220 kilometers. And that's the structure of the Earth. We're going to talk a lot more about what the Earth does, all the Earth processes as we go on, talk about the lithosphere. But I really hope you learned something today. I'm Mr. Norris, and I'm out for the lithosphere video.